Hello friends, myself Pramod. Today we are discussing the important topic of computer organization, that is Booth's algorithm. Basically Booth's algorithm is used for multiplying the two integers. Now let us see steps to be followed in Booth's algorithm. Number 1. Booth's algorithm is used to multiply two signed numbers. When we multiply two n-bit numbers, the answer is 2 into n-bit numbers. Three registers A, Q and M are used for this process, where Q is multiplier and M means multiplicand and A is accumulator. Here accumulator is initialized to 0 initially. At the end of the operation, the result will be stored in both accumulator and multiplier. The process involves addition, subtraction and shifting. Algorithm. The number of steps required is equal to the number of bits in the multiplier. At the beginning, consider an imaginary 0 beyond the least significant bit of multiplier. At each step, examine two adjacent multiplier bits from right to left. If the transition is from 0 to 1, then subtract M from A and right shift. Accumulator and multiplier is combined. If the transition is from 1 to 0, then add M to the accumulator and right shift both accumulator as well as multiplier. If the transition is from 0 to 0, then simply right shift. If the transition is from 1 to 1, then simply right shift. Repeat step 1 to 5 for all the bits of the multiplier. The final answer will be in both accumulator as well as in multiplier. Now let us look into one example, that is 5 into minus 7. 5 is multiplicand and minus 7 is multiplier. Here 5 in binary is 0 1 0 1 and minus 5 is 2's complement of 5 is 1 0 1 1 and 7 binary is 0 1 1 1 and 2's complement of this is minus 7, that is 1 0 0 1. Here initially accumulator is initialized to 0, multiplier is minus 7, that is 1 0 0 1, imaginary is 0, multiplicand is 5 0 1 0 1, and here the number of steps required is equal to number of bits. Step 1. Here the transition is from 0 to 1, then we have to subtract M from accumulator. Subtract M, that is, here it is positive, so we have to take 2 complement of this, that is 1 0 1 1. We have to add this 2's complement to the accumulator, 1 1 0 1, and this is 1 0 0 1 0. Now right shift, right shift. During right shift, whatever the number is there in the left significant digit, start with that number. That is here. So now we have to right shift this one, that is here the last number left LSD is 1, so we have to start with LSD 1 1 0 1 1 1 0 0 and this is 1. Now step 2. Step 2. Now the transition is from 1 to 0, so we have to do addition of multiplicand to the accumulator. Add M, that is 0 1 0 1. We directly add this 5 to this one accumulator. Here 1 0, sorry, this is 1 1 is 1 0 and it is 1 1 1 1 1 is 0 1 0, this is 1 1 1 is 0 1, 1 1 is 0, and carry is negative, and this is 1 1 0 0, and this is 1. Now we have to do right shift. That is, here the LSD is 0, so we have to start at 0. That is 0 0 0 1 0 1 1 0 0. Here the transition is from 0 to 0. Step 3. Here the transition is from 0 to 0, so we have to do only right shift. That is 0 0 0 0 1 0 1 1, and this 0 comes here, that is 0. Here the transition is from 0 to 1. Step 4. Here the transition is from 0 to 1, so we have to do subtraction. Subtract this m from accumulator. Subtract m. Okay. 0 0 0 1 0 1 1. I am writing this once again here only. Subtract m, that is, this is plus 5. Minus 5 is 1 0 1 1. 1 0 1 1. 1 1 0 1. 1 0 1 1 0. Now we have to do right shift. LSD is 1, therefore we have start with the LSD 1 1 0 1 1 1 0 1 1. By combining these two, accumulator as well as multiplier, we get minus 35. Minus 35. Two's complement of this is 35 plus 35. Okay, thank you.